Hi guys, in the last part of the video, we saw how we can oxidize aldehydes and looked at the generic mechanism for a nucleophilic addition. So now let's think about reducing aldehydes and ketones to alcohols. And remember, the definition of reduction can be adding hydrogen. To be able to add hydrogen, we need some hydrogen nucleophiles because it's going to be a nucleophilic addition reaction, as we saw the mechanism for in the last part of the video. Hydride ions, H-, will do the job of being a hydrogen nucleophile because they have a negative charge. We use sodium tetrahydride borate 3, NaBH4, as a source of these H- ions. And now let's just have a think about why it's called tetrahydride borate. Tetra means 4, and then the hydride refers to the 4 H- ions that provide the H- ions for the nucleophilic addition. The borate 3 refers to the central atom that all the hydrides are attached to, boron, which has a 3+ charge. We can now consider how to use this NaBH4 in the reduction of propanol. When the sodium tetrahydride borate is in solution, it releases H- ions, which we are going to show acting as nucleophiles. As we talked about in the last part of the video, the carbonyl group has a slightly negative oxygen and a slightly positive carbon, which is where the nucleophile attacks. So here the hydride ion is going to attack, an intermediate will be formed. The H- attacks with its pair of electrons into the carbon, and now because the carbon will have one too many covalent bonds, the pi bond to the oxygen will break, leaving the oxygen with a full negative charge, which is what makes the intermediate unstable. The intermediate will then react with a nearby molecule like water to gain a hydrogen, so it will donate its electrons to the hydrogen, and the hydrogen in turn will break its bond with whatever it's attached to. In water that would be OH, and this will make the molecule into a stable final product, which in this case is an alcohol. If we use an aldehyde, the C double bond O will have been on the end of the molecule, so we will end up with a primary alcohol, as shown here. If we used a ketone, the C double bond O carbonyl group would have been in the middle of the molecule.
Hey guys, to continue watching this video and unlock hundreds of other super concise exam board specific A-level chemistry videos, just click the snap revise smiley face here. Join me today, and together, let's make A-level chemistry a walk in the park.